Hello everyone, this is Dr. Sirisha, working for Institute of Aeronautical Engineering College. In these sessions nowadays, we are going with the videos on company-specific training. Just like my previous videos were on Amazon, TCS NQT, now I have started for Accenture. Now guys, you know that this is the time for on-campus placements. So Accenture is one of the most prominent company which hires freshers in a lot. And this company accepts freshers from CSE, IT, ECE, EEE and the remaining branches if they are good at coding. The conditions apply as I said, right? So the first round of almost all the companies which come to on campus will be MCQs round, that is multiple choice questions, because a lot of students will be there, so they are going to segregate them for the coding round based upon MCQs, multiple choice questions. So today I'm going to show you some of the pseudo codes which are most frequently, I don't mean these questions, these kind of questions most frequently asked in Accenture. So this will be a pseudo code specific video. Let's start this one. Yes, guys, I'm going to start with the simple pseudo code, the first snippet. Have a look at this piece of code. So what it is saying, it is talking about a function and it is asking what it is going to return. Right, what it is going to return. That is the primary question of this function. So, and as input, it is taking the values of A as 9 and B as 7. Right, now you have to evaluate. Guys, here you can see that modulo division is the basic operator that is being used. Then, what is mod? Mod is nothing but modulo division, which is one of the outputs of division operation. So coefficient and remainder are the two outputs of any division operator, and modulo division returns the remainder. Right? So let's start this one. So it has initialized the question itself. They have initialized A as 9 and B as 7, and within the function they have set C as 2. Right? So let's see this one. So what it is saying. So B, the evaluation part goes like this. B is equal to B mod C. What is the value of B? 7 mod 2. When you divide 7 is an odd number, right? If you do the modulo division with 2, the remainder will definitely be 1. Right? The similar logic we use if you want to check whether a given number is even number or odd number. Right? Similar one. So when you calculate the same operation for A mod C, that is 9 mod 2, the result will be 1. Now the new values of B and A are 1 and 1 respectively. If you return the value, so the loops are not there, in nothing to decide, not even decision making statements. After these two simple operations, they are asking us to return the value of A and A plus B. So what is the value of A plus B, guys? 1 plus 1, which is 2. So 2 will be the result. So 2 is the result of this question. Simple one, the first one, simple one. Let's go with the second pseudo. Right? So have a look at this one. So it is taking 3 values. So A, B, C, all 3 are of type integer, they are saying, and they have initialized the values as A is equal to 8, B is equal to 6, and C is equal to 4. So they have already used the set statement for the same. So set statement is initialization. It is not any reserved word of kind of thing. It is most prominent used word in pseudocodes. That's it. Okay. So let's go with the logic of the question. Here there are 2 if statements. If you can see, this is one structure if else and the other is this one. 2 structures are given over here. Right? You have to evaluate both. So it is not a nested one. One comes after the other. Okay. So let's evaluate. First one. 8 is greater than 6. That's what they have said. A is greater than B. As the condition gets satisfied, A gets the value of B, which is 6. Now, in the memory, A is overwritten by 6, right? As the if condition is true, else part will not be executed. So let's go to the second, and here is the statement for the end of the first if else structure, right? So let's go for the second condition checking, where it is checking C greater than B. What is the value of C? It's 4, which is greater than B, which is 6. Is the condition true? No, the condition fails. If the condition fails, the control will go to the else part. What the else part is saying? It is saying initialize the value of B to C. What is the value of C? Which is 4. So now B value in the memory will be overwritten by 4. So loops are not there. You need not recur anything. No iterations, guys. So both the if-else structures have been evaluated. Now the return statement is saying that return A plus B plus A. Yes, the latest values in the memory are 6 for A, 4 for B, and 4 for C. So the summation of that will be 14. So the following function, once evaluated, is going to return the value 14. So C is the right option. Let's go for the next one. Okay, even here we do not have any loop structures, no iterations, guys. Okay, this is a simple pseudocode, but if you look at this one, the one who is familiar to expressions as a condition will think that it is a simple one, but the other category, those who feel that it must be either true or false, that means if a person is expecting a logical operator or a relational operator in if, will fail to understand this, and they may think that this is logically wrong. So when we convert this pseudocode into a program using any programming language, it will definitely give compilation error. No, my dears, it is not like that. So any value, even a constant value also can decide whether the condition is either true or false. Okay, let's evaluate this one. Even in the pseudocode, they are talking about 3 variables, A, B, and C, and they are initialized as, so this is the set statement, guys. So A is 1, B is 1, and C is 7. So let me handle this in terms of memory. A is 1, B is 1, and C is 7. Okay, so now in the second statement, or the first expression in this one, they have changed the value as of A as A plus B, that is 1 plus 1, which is 2. So in the memory, the value of A will be overwritten by 2. It is no longer 1. Okay, so let's start the decision evaluation. So here it is saying if of A plus B. What is the value of A and B? That is 2 plus 1, which is 3. So if of 3, what do you mean by that? Very simple. Everything is true. Even negative values are true except 0 in any programming language, and that is the root of any pseudocode. Right? So you can convert this into any programming language of your wish. But if the value which you are talking about is other than 0, it is true. So 3 means it implies that the if condition is true. If the condition is true, it is going to enter into the body. So the body of the outer if is another if statement. Let's evaluate this one. So it is talking about B plus C XOR A. So here 2 operations are there. The first operator is arithmetic operator, and the second one is bitwise XOR. Okay, bitwise exclusive OR operation. So as a C XOR A is placed within brackets, the innermost one, it gets the highest priority and it will be evaluated first. So let's do the same. The value of C is 7. If you convert that into binary, you're going to get 0, 111. 4 bits are enough for me. The remaining will be on the left hand side will be zeros, so I'm not taking it as of now. A is 2. So take the current values, guys. Don't go with the values which are set, because it is in the next statement it has been overwritten. Okay, so 2 is 0 0 1 0, and an XOR operation will give you the result as 0 1 0 1. Why is it so? Because XOR operation tells you that if both the values are same, the resultant will be 0. If the values are different, the result will be 1. So if you convert this into decimal, what will be the value, guys? 2 per 0, 2 per 1, 2 square, 2 cube. So 4 plus 1. So 5 is the answer. So you can replace that. B is 1. 1 plus 5, which is 6. So if of 6, as I said earlier, it returns true. Any value other than 0 is true. So our condition is true over here, right? So if it is true, the body will be evaluated. What is the body saying? So it is saying that overwrite A with 2. Okay, guys, I'm going to overwrite A with 2. I have done it. And B will get a value of A. B will be overwritten by 2. Now in memory, both A and B are holding the same value, 2. Right? Fine. Now they didn't touch the value of C. They didn't change the value of C. So and if tells you that in the innermost if condition is over, and now they want you to print the value of A plus B plus C. So what is the sum of this, guys? 2 plus 2 plus 7. It is 11, right? 11 will be the answer for this question. Yes, right? So let's go for the next one. I hope you understood, guys. Please evaluate. Do not think that it is. See, here I have taken all the numericals as options, but to confuse you guys, most prominently in any, if they give any pseudo code or piece of code from any programming language, mostly Accenture do not go for it, but in TCS Executive we have seen that it goes from C pieces of code in language C and C++, Java, all three. Yes, pseudo codes obviously they'll be there, but in Accenture, as far as we have observed, so it goes and sticks to pseudo codes. Okay, so in one way it is a favorable condition for you guys. Okay, so yes, it's simple. Just whatever the variables they give and whatever the values they set, make a note of it and start overwriting it, thinking that it is the memory, main memory where the data is stored. So whenever you are using the values, retrieve from the memory rather than the set values. Then you'll get the accurate results. Okay, fine. With this note, let's go for the next one. Have a look at this one. Don't get panicked looking at this such huge big if condition out there. It's a simple one. Let's see, guys. They have taken again 3 variables and they're set to A is 30, B is 60 and C is 90 respectively. Okay, 3 values are set and they have initialized A, B, C and sum as integers. They have read the values, but you have to use the input values which they have given in the problem statement. Okay, now in the memory I have A is equal to 30, B is equal to 60, C is equal to 90, and after that in the evaluation they have taken sum as the summation of A plus B plus C, that is 60, 30, 90, which is sum will be 180. Guys, make a note that whatever I am writing over here is a part and parcel of the data which will be present in the memory. This is how it has been allocated. Okay, now let's come to the condition. So equals tells that it is equal to the operator, the relational operator, double equal to which we use in programming language, and not equals to is not equal to operator. These two are relational operators. Remember, always relational operators give the result in terms of either true or false. Okay, so to check the condition. And these relational operators are concatenated with our logical operator, guys, AND. 3 AND operations are given. Totally 4 conditions concatenated with logical operator AND. Okay, so let's write or replace the statement as it is. So if they are asking if sum, which is 180, is equal to 180, and so A is 30 not equal to 0, and B, which is 60 not equal to 0, and C, which is 90 not equal to 0. This is the condition they are talking about, right? So let's see whether it gets evaluated, whether these concatenate 4 conditions, right, when concatenated with logical AND, are going to turn to success or fail. Okay, guys, do not expect else keyword always. Otherwise is also a synonym for else in pseudocodes. Let me make it very clear, in terms of pseudocodes, not in any programming language. It is similar, it will be most frequently used in replacement with else. So if the condition is not true, go to the otherwise part or else part. Okay, right. So let's evaluate this. What is the result of 180 is equal to 180? It's true. Both are same. And what is the result of 30 not equal to 0? Even that is true. Coming to the next part, 60 not equal to 0, and that is true. And the last, 90 not equal to 0, even that is true. All the 4 conditions are true. So as they are concatenated with a logical AND operator, what will be the result, guys? So as it is AND always says that if all the conditions are true, the result will be true. Even if at least one gets failed, the whole condition is failed, right? But here, God's grace, all the 4 conditions are true, so our result is true. So as the result is true, it is going to execute its body and it is going to print success. So otherwise will not get executed, only if the condition fails, otherwise it's going to get executed. So the output will be a success, right? So there is nothing wrong in the pseudo code, okay? And as per the second one, none of the mentioned options is also not true. Yes, and it is not a fail case also. Okay, I hope you got the execution of that. If guys, these are simple ones. If you practice a lot, it will be cakewalk for you. But even if it is not, please do not get panic. Whatever programming language you are good at, whether it is C, Python or Java, convert that pseudo into simple logic in your well-known programming language, then it will be easier for you. Just like as I have converted that into C, right? Yes. Let's go for the next one. Here is the next pseudo code, guys. Yes. It is a function fun, right? Which is taking 2 values, integer values, more specifically A and B. And it is having a return value also. That means this function is going to return some value which is of type integer, right? So let's start. So the values of A and B are 1 and 2. So 1 and 2. So the parameters of the function fun are 1 and 2 respectively. So let's start the evaluation. So the first condition, the first function call, as you can see clearly that, let me make it clear. See, if the else part is true, it is going to return just A plus B. Whatever the value of A added to whatever the value of B, and khel khatam dukandar. But what if the condition if is true? It is calling itself with the new values, with the new parameters, right? If a function calling itself, what do we call it? We call it as recursion, right? So it is a recursive call. The fun is calling itself. It is calling itself, right? So be careful while evaluation when a function is calling itself. So you have to, you just try to draw a picture of the same. It's like a structure, tree structure of the same, of the simple evaluation. It will be easier for you. I just draw it. If you feel comfortable, you can follow the same, right? So let's have it. So first call will be fun of 1, 2. Okay, so within that, I am going to use indentation to make it easier. Okay, so if the condition is saying 1 is less than 3 and 2 is less than 4. Yes, till now we were talking about relational and logical AND operator. So I'm not going to explain once again. So 1 is less than 3 is true and 2 is less than 4 is true. So the condition overall is true. So as it is true, it is going to call, it is going to execute its body, which is return of fun of a plus 1. What is the value of a? 1. 1 plus 1 is 2. And b plus 1, what is the value of b? 2. 2 plus 1, 3. This is a recursive call. In this call, again, it is going to evaluate the same. If 2 is less than 3 and 3 is less than 4, right? So 2 is less than 3 is true and 3 is less than 4 is true. Overall, the condition is true. As the condition is true, again its body is going to get executed with the new values. What are the new values, guys? What is the value of a in this function? 2. So 2 plus 1, it is 3 and b value is 3. 3 plus 1 is 4. So again the function call, the body gets executed if 3 is less than 3 and 4 is less than 4. Guys, have a look. 3 is less than 3 is false and 4 is less than 4 is false. Right? Overall the condition fails. If the condition fails, what is the part that is going to get executed? The else part. What is the else part is saying? To return the value of a plus b. What are the values of a and b in this function? That is, in this function, the value of a is 3 and b is 4. So it is going to return 7. So it is going to return 7. Once it is done, where the control is going to go? To the one who have called. Its body got executed to the one who have called, and here is the function who have called, who was saying that after the execution of if all the recursive call end the function. That is the end of the function. So overall this whole structure, what is the value that is being returned? The value that is being returned is 7, and that will be the right answer. Okay guys, you need to backtrack also. And one more key point I would like to mention over here is about this statement. So what a small extension of our discussion, guys. If 3 is less than 3 is concatenated with the logical and 4 less than 4. So how is it internally evaluated, right? So 3 and 3 is going to result as false. Am I right? So as it is concatenated with end says that if at least one condition is false, the whole statement itself, the whole condition itself is false. If one statement is false, so it is not going to even evaluate this, whatever it may be, even if it is, say for example, not in this current problem pseudocode, if it is 4 less than or equal to 4, even though it returns true, it will not even calculate that. It will not even evaluate. It will not even check for the relation between them. Okay. So in logical AND operators, if the first condition, if it is concatenated between more than one conditions, right, at any ith condition, if it is false, I plus 1th conditions will not be checked. Okay, this is the sub point in this one. So I hope you understood the recursion of the function fun. Again, I have taken a huge example, guys. Even this is an example of recursion. Have a look at this one. Loops are not there. Today I'm just going and working on just if functions and recursions. Okay. So have a look. The values of A and B are initialized as 2 and 6 respectively. A is 2, B is 6. They are checking if, and within the body of if you have another if, that is a nested if, I can say, right? You can say it as a nested. And there are recursive function calls. 3 recursive function calls are there, my dears. So be careful. Don't get panic looking at this question. It's a quite simple one. If you start evaluating, you'll understand it. So first of all, let me replace it. 2 greater than 0. Yes, the condition is true. 6 greater than 0. Yes, the condition is true. It is going to return 2 plus 6. A plus B they have said. I have replaced it. So fun of, what is the value of A? It is 2. 2 plus 1. So it is 3, 0 plus fun of A plus 2. So A value is 2. 2 plus 2, 4. 0 plus fun of 2 plus 3, 5. Right? So 3 functions. 3 function calls, or the fun is calling itself. Let me evaluate this. The first recursion this will be called. So fun of 3, 0. That means it is going to enter the body and it is going to check if 3 is greater than 0. Yes, condition is satisfied. Inside the body, B is greater than 0. 0 is greater than 0. Oh my god, the condition fails. So even though this condition is true, but this condition is false. So there is no further body for the outer if also. So nothing will be executed, but it is going to return. That means it is going to reach the end of if, right? And it is going to return the value, that is A plus B. What is the value of A, guys? It is 3. And what is the value of B? It is 0. So it is going to return 3 plus 0, which is 3. Let's go with the next one. So if 4 greater than 0 condition is true, get inside the body. If B value is 0, 0 greater than 0, again the condition fails. So there is nothing inside the outer if to get executed as the first statement. If B greater than 0 is a failure, it will straight away go to the written statement. It will straight away go to the written statement which says return the value of A plus B. What is the value of A, guys? It is 4 and B is 0. 4 plus 0, 4 it is going to return. Okay, let's go for the last one. So if 5 is greater than 0, condition is true. Inside the body, if 0 is greater than 0, condition fails. As the condition fails, so even here the same story repeats which we were seeing in the last 2 turns. It is going to return the value of 5 plus 0, which is A plus B. So it is going to return 5 plus 0, 5. So overall, what is the return of this one? So it is 2 plus 6 plus 3 plus 4 plus 5. What is the value, guys? 10, 10, 20 is the answer. See, have huge statement, 3 recursions, but how silly it is. So the answer is D, which is 20. Hope I'm clear with this. Let's go with the next one. Yes, guys, one more simple one. Let's evaluate this one. Even here, recursive function is being used, but with some new values. Let's see. So A is 4 and B is 6. This is the initialization. So A is 4, B is 6. So that checking, is 4 greater than 2? Yes, condition satisfied. Is 6 greater than 2? Yes, the condition is satisfied. You have to return, if the condition, all these conditions are true, you have to return A. What is the value of A? 4 plus 6 plus fun of A plus 1. What is the value of A? 4. 4 plus 1, 5. B. A is 4, B is 6, guys. Let me replace it. 6 minus 5, 1. This is again a function call, right? Recursive function call. Let me evaluate this one. So if the value of A in this current function call will be 5. So is 5 greater than 2? The condition is true. Inside it, if B 1 greater than 2, the condition fails. So the body is not going to get executed. So if the body is not going to execute it, where the control is going to go? It is going to get the end of this inside end if. Okay. So as there is no other statement in outer if, so even it is going to enter end if, and it is going to return A minus B. What is the value of A? 5. B is 1. So 5 minus 1. So it is going to return 4. So overall, when you come to the return statement of our main function, 4 plus 6 plus the return value of this recursive function, which is 4. So the answer is 14. Okay. So this is how these pseudocodes, simple pseudocodes will be evaluated, guys. So let's go with the next one. Yes. Here is a simple code. No recursions, no functions, nothing. But as you can see, they are talking about bitwise AND and bitwise XOR operators. So guys, if I make a list of the operators which are present in my if condition, I have a lot. So it is P plus a lot. Okay, let me make a count of operators. It is addition, bitwise, logical AND. Okay, fine, good. So do you need to evaluate all? Let me evaluate all, and later we'll think of what extra work we have done. Okay, fine. Let me replace the values of it with numericals over here. So P is being set with 3, Q as 1 and R as 2. Let me replace it. So 3 plus 2 and 2 and 2 with logical Q is 1 plus 3 and 3 and 3 with the logical end of 2 plus 2 exclusive 2 exclusive 2. Yes, guys, let's evaluate it. So out of all these operations, guys, the brackets will get the highest priority. Just recollect your operator precedences where brackets will get the highest priority. If there are nested brackets, the innermost bracket will get the highest priority. So here, if you start from left to right, this will be the first operation that will be evaluated. So what it is saying, bitwise AND, right? So what is the bit value of 2? So it is 0, 0, 1, 0. And another 2, 0, 0, 1, 0. So it will be 0, 0, 1, 0. 2 only. Okay, if you go for bitwise AND. And another 2. 3 2s are there, my dears. So another 2, 0, 0, 1, 0. So a bitwise AND of that will give you 0, 0, 1, 0. So even this is 2, right? So what did you conclude with this? We just conclude that n, if you take a value n and end of logical AND with n, you can do it any number of times, the result will be n. There is no change in it. Okay, so let's, with that funda, I can say that the result of this operation is 2. Okay, so the same funda goes with the 3. It is 3. No need to calculate. If you want manually, guys, most welcome, do it. Okay, let's evaluate the third brackets, that is 2 XOR 2 XOR 2. Very good. So again, If I let me override this one, guys, I don't want to mess it up with loads of calculations. So, 2, if I perform XOR, what XOR talks about? XOR tells that if the inputs are different, the result will be true or 1, or else it is 0. If you perform exclusive of operation of n with n, any nth value with n, the bit values will be as it is. That means 0 with 0, 1 with 2, it will go like that only. So its operation will always be 0. So remember one more lesson for you. N exclusive n will always be bigger down. Okay, right. So again, but it is having 3 guys, 3 2's concatenated with bitwise XOR, right? So 0 0 1 0. So 0 0 1 0. The answer is 2. Right? Very good. Right. So the answer is 2. So let's evaluate this. Because these values are even concatenated with this bit logical operators, that is logical AND operations. Let's do that. So let me rewrite. It is a bit clumsy. So 3 plus 2 and 1 plus 3 and 2 plus 2. Okay, so we have arithmetic operations and logical operators, logical AND operators. Let me evaluate the logicals ones. So 2 and 1 will always be true. So 3 is a value which is other than 0, so it's true. So 3 and 2 both are values other than 0, so it is true. Even 2 will return true. Whatever the result it may be, the whole result is true. It is not going to be 0. So overall, the gist of the story is that whatever the huge expression given in if condition is, it is true. As it is true, the body of if is going to get executed, which says p is equal to p minus 2. It is the value of p. 3 minus 2, which is 1, and q is being overwritten with the value of p, which is 1. So these are the latest values of p and q minus. Okay, once this structure is done, else part is no way going to get executed, because if condition was true and its body got executed, so else body part is not going to get executed. Thereby it is going to get to the last statement of your code, which says after and if add the values of p, q, r and print it. So what are the values of p plus q plus r? Fetch it from memory, guys. 1 plus 1 plus r value, we didn't touch it anywhere, we didn't modify it. It is true. So total is 4. 4 is the answer. Okay, 4 is the answer. Right? So I hope this was a bit clear for you guys how to evaluate these things. So whenever you find bitwise, convert them into bits. If you do more and more, it will be easy for you guys. So remember the 2 lessons. N XOR n will always be 0. N end of n, any number of times you do bitwise n, you will get the value as n only. Okay, good. The next one, or let me say it as the last one for today's session, guys. So in this pseudo code, 3 values are given, p, q, r, and they are set as p is equal to 0, q is equal to 4, and r is equal to 3. So if they are checking for, here they have used OR also, logical OR. Okay, so this will be replaced by if 0 or 3. Okay, what logical OR operation says? It says that if at least one condition is true, the result will be true. So here, if coming to the first operand, it is going to return false. The second one is going to return true. So false or true is true. So the result of this one is true. So as it is true, it will go inside the body of if, which is an another if condition, which says P and logical end of R. So P value is 0, logical end of R, which is 3. So a logical end, it says that all the conditions must be true. Okay, so this is false and true. 3 is true. So the result is false. The body is not going to get executed, guys. So thereby, this part where P is being reinitialized as P, bitwise and R will not be executed. Otherwise, it will going to come out of it and it's going to get executed with P is equal to P XOR R. Right? What is the value of P? It is zeros. R, it is 3, 0, 0, 1, 1. And you perform XOR 0, 0, 1, 1. What did I tell about XOR? If the data is different in nature, the result will be 1. If it is same, it will be 0. So the result of this is 3, right? So now P is overwritten by 3. It is no longer 0. Guys, let me change it in memory. It is 3. Okay, so P got a new value which is 3. So by the end of the body of outer if also got ended, and the last statement of the code says that print the value of summation of the 3, P plus Q plus R, which is 10 if I'm not. So yes, the answer is A, which is 10. Okay, so I hope working with the bitwise and logical operators is quite easy for you guys enough. So just whatever the pseudo code they give, try to expand it. Put numericals and expand it. Easy, it will be easy for you to evaluate. Okay, I hope this session was useful for you. Thank you and keep following me.
Like, share and subscribe. Hit the bell icon for more updates.